Hey everybody, today we are going to keep practicing what we learned yesterday in the Trigonometry 2 notes. We have brand new buttons on our calculator that we're trying to get used to. We're trying to get used to what is sine, what is cosine, what is tangent. How does that relate to anything at all? We can use it to find missing sides. In a right triangle, we can use it to find missing angles. There are all sorts of things we can do. Now, the cheesy phrase that we use to memorize the ratios was Sohcahtoa. Now, if you did not watch the Trig 2 notes video, then you definitely need to go back and do it, and you need to do these things in order because it's not going to make any sense whatsoever. As it is, it's already kind of a difficult process. Long story short, if you're doing the sine of an angle, it is the ratio of the opposite side to the hypotenuse. That's our first rule. That's our first ratio. Now I bring that up here. On the very first question, it says find the sine of the angle, find the cosine of the angle, and find the tangent of the angle. So we could start there. But actually, we're probably going to want to figure out what that side is first. So we should probably do the Pythagorean Theorem here just to get a jump start. So we're going to do 15 squared plus 20 squared equals c squared. Add those up, and you get 625, which is actually a perfect square. It turns out 25 is going to be that missing side, which means we can answer this first question, and we can say that the sine of that angle is, like I said before, opposite over hypotenuse. The opposite side, that's the one farthest away, is 20. And then the hypotenuse, the largest side, is 25. Now you definitely want to reduce any chance you get, so I'm actually going to take that 20 over 25. You can rewrite it. I'm just going to save myself some room here. Call it 4 over 5. All right. The cosine of that missing angle, if we go back to our listing here with our ratios, the cosine of an angle is going to be equal to, the cheesy phrase says CAH, Sohcahtoa. So we're going to use A and H. A on top, and then H on bottom. So we're still going to, in our practice problem, put a 25 down below. But this time it's going to be adjacent. Adjacent is a fancy way of saying next door neighbor. So it's going to be 15 over 25. And again, I want to save room, so I'm going to reduce that. You can just rewrite it. Either way, it's going to be 3 over 5. All right, and then last but not least, we're going to do the tangent of angle theta. It's the missing angle right there. And the rule for tangent is that it's equal to the opposite over the adjacent, Toa. Okay, so that cheesy phrase, tells you everything you need to know. It tells you in order what goes in the numerator and what goes in the denominator for each trig ratio. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you do the opposite, you get 20. If you do the adjacent, you get 15. So you get 20 over 15. And then, like I said, I'm going to save myself some room, and I'm going to erase it and reduce. I just want you to rewrite it, and you would get 4 over 3. Okay. Now, the next examples, these are the ones that I think are really, really at the core of practicing your right triangle trigonometry. Examples 2, 3, and 4. Okay, so when it says solve for x, that means we have an angle, we have a missing side, and we can't do the Pythagorean theorem. The reason being, with the Pythagorean theorem, you would need to know two sides and find the third. Here, all we are given is one side and one angle, and we have to work through it. All right, so we're going to practice what we did yesterday. We're going to try to go over what do we know and what do we want to know. Now, in problem number 2, example number 2, what we know is the opposite. We know that the opposite side to the angle we're given is 9. What we want to know is the adjacent. That's the next door neighbor. So we know the opposite. We want to know the adjacent. And according to the cheesy phrase, Sohcahtoa, the trig function that uses O and A is going to be tangent. So we're going to use the tangent function, and we're going to set it up like this. Tangent of 49 equals, and then opposite over adjacent. So we're going to do 9 over x. Now from here, like I said, I'm not going to reinvent the wheel. I'm going to do what you already know how to do, and I'm just going to put the left side of the equation over 1, and I'm just going to have you cross multiply. 9 times 1 is 9. X times the tangent of 49 is x times the tangent of 49. Please don't overthink this. Okay. So then you only have one thing that you need to do if you want to get x by itself, and that would be divide both sides by the tangent of 49. And remember, that's just a number. You know, tangent of 49, if you were to throw it in on your calculator, it's just a number. It's really not a big deal to divide by the tangent of 49 because it really is just a number that you would have on your calculator. All right, now, when we do this on a calculator, if you missed yesterday's video, go back and watch it. You have to make sure your calculator is in degree mode. You can do angles with degrees or something called radians, and we're not going to learn about that yet. So you need to make sure you are in degree mode. And then from there, you could just do, like I said, 9 divided by the tangent of 49. And you would be able to figure out the missing side, which is 7.8. We'll do 7.82. All right, let's go to example number 3. So I'm going to do the exact same process I did last time. What do you know and what do you want to know? I think that's a really good way of laying it out. In this case, based on the angle that we're given, the thing that we know is actually the hypotenuse. Well, no matter what the angle is, the thing that you know is the hypotenuse. It is the longest side. It is the one opposite the right angle. The thing that we want to know is the one opposite the angle we're given. So again, the one that we know is the hypotenuse. That is the biggest side. Yesterday we talked about making an educated guess. If we know the hypotenuse is 32, that means every other side has got to be less than 32. Okay, we know the hypotenuse. We want to know the opposite. That's the one farthest away. So if you're wondering about adjacent, adjacent is your next door neighbor side. We don't want it. We don't want to know it. It doesn't really matter. The trig function that uses opposite and hypotenuse is sine. So I'm going to say sine of 28 equals, and according to the cheesy phrase, Sohcahtoa, the order is opposite first and then hypotenuse second. So we're just going to say opposite is x, hypotenuse is 32. I like it when it gets set up this way because if the x is on top, I'm only going to have to do one step. If I cross multiply, I'm going to get x times 1, which is x. And then 32 times the sine of 28 is 32 times the sine of 28. Throw it in. Let's go. 32 times the sine of 28. Now, if that was a 30, 60, 90 triangle, then x would be half of 32. So my guess is about 16. Let's see how good we are. Hey, okay, that's not bad. 15. 15.02. Not bad. All right, last example of this type. Make sure you pause if you need extra help. So you have a missing hypotenuse, okay? And you're given the 15 down here. So this time, the thing that you know is the adjacent, because if you look at the angle that you're given, which is the 56-degree angle, and then you look to the next door neighbor. So the angle we're talking about is this one right here. 15 is the next door neighbor. And then x is the hypotenuse. That's what we want to know. So that means we need to find the rule that uses the letter A and the letter H. That would be cosine. And that makes pretty good sense because we just did an example with tangent and an example with sine, so it makes pretty good sense that we are going to use cosine. So cosine of 56 equals the adjacent, which is 15, over the hypotenuse, which is x. All right, so cosine of 56 over 1. So that's going to give me 15 equals x times the cosine of 56. Then, to finish off the problem, I'm going to try to sneak it in here because I'm running out of room. To finish off the problem, you're going to have to divide both sides by the cosine of 56. Now again, I brought this up in the previous video. You talk about guessing. The hypotenuse here looks like about twice as big as the adjacent side. Maybe not quite, but almost. So I'm going to say maybe a little less than 30. I don't know. We'll find out. 15 divided by the cosine of 56 is, all right, that's not bad, 26.82, so about 27. So my guess was not too bad. All right, so if you are trying to get caught up, make sure you know what you're doing. Let me leave these first four up just for a second, and then we will go over the last four. The last four will be much, much faster, I promise. Okay, we'll zoom in on the last four here in about 2 seconds. Okay, there was 2 seconds. All right. We'll go to number 5. Find the value of x and y without a calculator. All right. So in the past, we have done the special triangles, and then recently we have done extra practice trying to get you to remember everything you used to know at one point about special triangles. If you know your special triangles, then you will not have to do any trig work on that type, and you can pretty much just work through it off of memory. So that's why it's so important here. So if you look at example 5, this is the way I've been teaching it all year, so this should look really familiar to you. If you have a triangle that has a right angle and a 60-degree angle, it was half of an equilateral triangle. So you can sort of visualize it as half of an equilateral right here by drawing the other half in. If it's half of an equilateral triangle, that means that x value right there is half of 70. And then, I don't know if you remember this or not, we practiced it, it came up. Hopefully you remember, this is the one where if you take the little guy and you tack on a radical 3, you will get what you're looking for. Okay. Example 6. If you have a 45-degree angle and a 90-degree angle, then that means the other angle is also 45 degrees. And if you have two of the same angle, then that means you also have two of the same side. Now, this particular triangle shortcut does not use radical 3, it uses radical 2. Okay. Now, if it seems like I'm kind of rushing through that, it's because this is probably the 3rd or 4th time you've seen it, but I just wanted to make sure you had a refresher. Okay, so the 30, 60, 90 rule involves radical 3. The 45, 45, 90 rule involves radical 2. All right, last 2 problems that we're going to do together. What is the degree measure? Aha, so here's what we're going to do. This time around, we have been given 2 sides. So if we try to break down what do we know, well, we actually know the adjacent and the hypotenuse. What we are missing, the thing that we want to know, is the angle. Now, I actually really like these problems a lot. I think they make sense. They're really easy to set up using a calculator. According to our acronym, our little Sohcahtoa thing, cosine is the ratio that uses adjacent and hypotenuse. So the cosine of theta equals, and we have to go in the order from the rule, adjacent first and then hypotenuse next. The adjacent is 23, and actually your calculator will give you an error if you set it up the wrong way, because cosine cannot be bigger than 1, but that's another conversation that we'll get into as we learn more about our trig functions. All right, so then how do you work backwards to find the missing angle? Well, your calculator does it. It's the inverse function right there. It's the one with the -1 next to it. Okay. Most calculators have it. If you hit the second button on whatever calculator you're using, it usually pops up. And if you just hit enter, it will give you the measure of the angle, which in this case is 44.05 degrees. All right, so that brings us to our last question of the day. Same idea, but this time we're dealing with a pretty big angle. It opens really wide over there. Let's take a look here. We know So if we're basing our work on this angle right here, we know the opposite. We know the adjacent. Okay, so let's break this down. We know the opposite. We know the adjacent. And again, the thing that we want to know is the missing angle. According to our rules, Sohcahtoa, we're talking tangent. So the tangent of the angle that we're talking about equals opposite over adjacent. So 28 over 8. Okay, so that should give us a pretty big angle. The way that we're going to figure out what that angle is we're going to work backwards using the inverse tangent, kind of like what we did on the previous problem. We're expecting a pretty big answer because that angle opened pretty wide. I'm guessing maybe something in the 70s. I don't know. There you go. 74.05 degrees. It's interesting. They both ended up as 0.05. All right, so I hope that helps you get a jump start. Take a look at the directions on the website for which problems you are expected to try yourself. Thanks for watching. Take care of yourselves. Have a great day, and I'll see you next time.